Hey guys, it's Mr. Dugal, and today we're going to talk about prime factorization. And basically with prime factorization, we want to be able to tell what's at its roots. So I like to think about prime factorization. These are going to be hideous trees, but that's what we have here. So basically, for example, with a number like 36, we start at 36 and we try to figure out what's at its roots, what's at its very core. So we can actually start with any two numbers. So let's say, for example, 6 and 6. 36 is actually a perfect square, meaning that a number times itself equals that number. So 6 times itself equals 36. We can break that down into 3 and 2, and again 3 and 2. So at its root, we say 3 times 3 times 2 times 2. Or another way to write this as we start to get into squares is 3 squared. And what that means is 3 times itself. We have 2 3's. 3 squared is 9. This is different than 3 times 2. That would be 6. We're saying that 3 squared is 9. And over here we have 2 squared is 4. So we're left with 3 squared and 2 squared at its roots. And when we think about that, that would be 9 times 4, because 3 times itself is 9 and 2 times itself is 4. 9 times 4 is 36. When we look at our example up top, we are left with the same thing. 3 times 3 is 9, times 2 is 18, times 2 is 36. So prime factorization is when we take a number like 36 and we try to break it down to its very roots. Okay, one more example with the number 48. We're given 48. First example, first factor pair that I can think of is 12 and 4. Again, there's other things that we can start with, but it will always have the same result. To prove this, I'm actually going to start with 2 factor pairs. So we could also have done 8 and 6, for example. If I break down 12 and 4, I'm left with 4, 3, 2, and 2. I'm going to start highlighting them once the number is prime. This is called prime factorization because the roots should all be prime numbers. We don't stop until we're at a place where all of our numbers are prime. And this, in the previous example, you'll notice that the 2 6's were not prime, so we kept going. Just so happened that 3 and 2 were prime, and 3 and 2 were prime again. In this case, we have 2 is prime, 2 is prime, 3 is prime, 4 is not prime, so we need to keep going with that. We would be left with 2 and 2, which are both prime. On the other side with 48, it would have been 4 and 2, 3 and 2. And we're already at the point where we now exactly mirror what we had with 12 and 4. 2, 3, 2 are prime. 4 is not prime, so we take it one more step further. We're left with 2, 2, 2, 3, and 2. In both cases, we're left with 4 2's. So we're left with 2 times 2 times 2 times 2 times 1, 3. Rewritten, we would say 2 to the 4th power, because there are 4 2's, times 3. We could write 3 to the 1st power. That's the same thing as saying 3. Now remember, 2 to the 4th is different than saying 2 times 4. 2 times 2 here is 4, times another 2 is 8, times another 2 is 16. So 2 to the 4th is actually 16. And when we do 16 times 3, it equals 48. So there is our prime factorization for 48. Prime factorization is extremely important because it's the building blocks for all other numbers. And basically, it is also the foundation for a lot of things that you'll do moving forward in middle school math, such as adding fractions, converting mixed numbers to fractions, ratios, all of these things. This is one of our building blocks that is very important to know. Hopefully this serves as a solid foundation for how to do prime factorization. Thanks so much for watching.